Betelgeuse or Betelgeuse. It's a red giant star. If you put it where the sun is, it would extend out to the orbit of Jupiter. It's enormous. It's very unstable. It's about to explode.
They are among the biggest explosions of radio energy in the entire universe.
Something strange is happening in the skies, and it's got the attention of some of the world's most respected astrophysicists. Among them is Professor Brian Cox, who recently issued a stunning warning. Betelgeuse, one of the brightest and most well-known stars in our night sky, may be on the verge of a cataclysmic supernova explosion. This isn't just a dramatic astronomical event. If it happens, it could light up our skies for months and potentially change how we view our cosmic neighborhood forever. Betelgeuse. Located in the Orion constellation, Betelgeuse has long captivated astronomers with its fiery red hue and erratic behavior. But recently, something strange has been unfolding. It dimmed, then it brightened, then it pulsed with an intensity no one expected. And now, all signs are pointing to one possible outcome: a supernova, possibly sooner than anyone predicted. Betelgeuse is no ordinary star. It's a red supergiant, meaning it's reached the late stages of its life cycle. Roughly 700 light-years from Earth, this massive stellar body is about 1,000 times the size of our Sun. If it were placed at the center of our solar system, its surface would extend beyond the orbit of Jupiter. That's how immense it is. But immense stars burn fast and die young. And Betelgeuse is showing all the telltale signs of a star nearing its end. Brian Cox, known for simplifying the complex beauty of physics for audiences around the world, recently drew attention to the mounting data surrounding Betelgeuse. According to Cox, the fluctuations in brightness, combined with a sudden spike in infrared and ultraviolet emissions, could indicate that the core of the star is collapsing. If that's true, the explosion would be visible from Earth, even during the day. To put that into perspective, imagine looking up at the sky and seeing a second sun, not just for a few minutes or hours, but for weeks. That's the kind of brilliance a Betelgeuse supernova would unleash. But how do scientists know it's close? And more importantly, what would such a cosmic event mean for Earth and the surrounding solar systems? To answer that, we need to look deeper into how massive stars like Betelgeuse die. All stars operate on a delicate balance between gravity pulling inward and nuclear fusion pushing outward. In the case of Betelgeuse, it's been fusing heavier and heavier elements in its core. Hydrogen, helium, carbon, all fuse to generate the immense energy that holds the star together. But there's a limit. Once the star starts producing iron, the fusion process can no longer produce energy. At that point, gravity wins. And when gravity wins, the core collapses in a fraction of a second. This triggers a shockwave that blasts the outer layers of the star into space, a supernova. The energy released in this process is unimaginable. In mere moments, Betelgeuse would outshine entire galaxies. It would release more energy than our Sun will emit over its entire lifetime. But is this really about to happen? Brian Cox isn't claiming that Betelgeuse will explode tomorrow, but he's emphasizing the unusual behavior we're seeing now. The problem is, in astronomical terms, soon could mean tomorrow, or it could mean in 100,000 years. However, Betelgeuse's recent dimming event, which scientists dubbed the Great Dimming of 2019 to 2020, sparked renewed interest. At the time, the star's brightness dropped by nearly 60%, something never seen before. Astronomers initially thought a cloud of dust might be obscuring it, but further studies showed the surface of the star had actually cooled, indicating possible internal convulsions. This cooling could have been a surface sign of deeper instability. Cox and other astrophysicists believe that such events are characteristic of a star entering the final stages of its life. And there's more. Recent infrared observations from space telescopes like the James Webb have revealed intense mass loss from Betelgeuse. It's shedding its outer layers at an accelerating rate. That's another strong indicator of an impending collapse. Stars nearing supernova often blow off large amounts of material as their internal structures destabilize. Betelgeuse has been losing mass faster than ever observed before, forming a strange and expanding cloud around it. If Betelgeuse does explode in our lifetimes, the experience for humanity would be both awe-inspiring and scientifically invaluable. First, there would be no danger to Earth. Despite its size and energy, Betelgeuse is far enough away that its radiation would dissipate long before reaching us. So, while it may be dazzling to look at, it won't harm our planet. But what we would witness would be something no human has recorded in modern history. The last supernova visible to the naked eye occurred in 1604, when Kepler's supernova appeared in the constellation Ophiuchus. That explosion was so bright it could be seen during the day for weeks. Betelgeuse would be even brighter. Cox's warning isn't meant to cause fear. It's meant to draw attention to the rare opportunity we may soon have to study a nearby supernova in real time. From neutrino bursts to gravitational waves, a Betelgeuse explosion would allow astronomers to gather invaluable data about how stars die and how elements essential to life, like carbon, oxygen, and iron, are scattered throughout the cosmos. Every atom in our bodies came from such explosions billions of years ago. In a way, watching Betelgeuse explode would be watching the process that made us possible, happening all over again. The implications go beyond pure science. The cultural and philosophical impact would be enormous. Imagine telling future generations that we saw a supernova with our own eyes, that we watched a star die in real time. Ancient civilizations recorded such events in their mythology and history. The Chinese, Egyptians, and Babylonians all noted bright stars that appeared suddenly, lingered, then vanished. In modern times, we'd have cameras, telescopes, and satellites recording every moment. Betelgeuse's death could unify global attention toward the cosmos in a way nothing else has. But how close are we really? Let's look at the evidence stacking up. First, the irregular dimming in 2019 to 2020 was unprecedented. Then came an even more dramatic brightening. After that, new patterns of pulsation in the star's surface were detected, as if Betelgeuse were convulsing. Each pulsation pushes gas outward, sometimes faster than the speed of sound in space, and the star has started to form strange protrusions in its extended atmosphere. These could be indicators of an unstable envelope, the kind of activity that often precedes core collapse. Add to that the thermal images from orbiting observatories showing hotspots moving across the star's surface, and you have a picture of a star in turmoil. And that turmoil is what Brian Cox points to with cautious urgency. While other scientists are focused on gathering more data, Cox is uniquely skilled at bringing the cosmic narrative to the public in a way that makes it both understandable and urgent. He describes Betelgeuse as a ticking clock, not because we know the exact moment it will explode, but because we know that every pulse, every ejection of mass, every change in brightness is a tick closer to its inevitable fate. The star is dying, and when it dies, we will all bear witness. And still, one of the most captivating aspects of this potential supernova event is what it would teach us about the life cycle of stars and the broader mechanics of the universe. Brian Cox emphasizes this point again and again. We live in an age where science allows us not just to observe, but to understand. To take the pulsing signals from a distant red supergiant and decode them into a narrative of cosmic life and death. Betelgeuse isn't just some light in the night sky. It's a living furnace of elemental creation, and its collapse would mark the transformation of matter on an unimaginable scale. Every moment that passes brings us closer to a clearer picture of how stars end their lives and how their deaths feed the birth of new stars, new planets, and possibly even new life. The supernova of Betelgeuse would not only be visible with the naked eye, but it would also send ripples across space-time itself. Telescopes on Earth and in orbit would capture the explosion in multiple wavelengths: visible, infrared, ultraviolet, X-ray, and gamma-ray. But perhaps even more thrilling would be the detection of gravitational waves and neutrinos. These invisible signals would arrive moments before the actual light of the explosion, providing an early warning of sorts and offering a treasure trove of data for physicists around the world. The collapse of Betelgeuse would allow researchers to observe how the structure of space warps and vibrates when massive amounts of mass are suddenly rearranged. This kind of data is rare, astronomically rare. So rare, in fact, that many physicists devote their entire careers to preparing for an event that may never happen in their lifetime. And now, with Betelgeuse showing signs of impending collapse, that event might finally be within reach. For the scientific community, it's like preparing for the Olympics of astronomy. Observatories around the world have already begun collaborating, fine-tuning their sensors, calibrating their instruments, and setting up automatic alert systems to detect the earliest signs of a supernova. Brian Cox, with his unique blend of scientific rigor and poetic storytelling, paints this picture vividly. He doesn't frame Betelgeuse's end as a disaster, far from it. He frames it as a beginning, a chance to look into the very furnace where the atoms that make up our bodies were forged. A supernova is not an ending, but a rebirth. It disperses heavy elements into the surrounding space, fertilizing the galaxy with the ingredients needed for new stars, planets, and eventually life. It's cosmic recycling on a scale we can barely comprehend. And there's a certain humility in that. To know that everything we are, every atom in our blood, bones, and breath, was once part of a star just like Betelgeuse. When it explodes, it won't just be a spectacle. It will be a reminder of our place in the universe. A moment to reflect on how interconnected everything truly is. Cox often talks about this connection, how the universe isn't separate from us, but within us. Watching a star die in real time would make that idea feel real in a way few other experiences could. There are, of course, still debates within the scientific community. Some astronomers argue that Betelgeuse's fluctuations are just part of a long-term cycle we haven't fully mapped yet. Red supergiants are known for their instability, and it's possible that these signs are dramatic but not necessarily terminal. Others believe that we're seeing the very end stages, the kind that precede core collapse within a human timeframe. The truth is, no one knows for sure. That's why Cox's warning is framed not in panic, but in curiosity and anticipation. What makes Betelgeuse's case so fascinating is the timing. Humanity has only just begun to build the tools necessary to watch a supernova unfold in real time. 100 years ago, we would have seen only a bright dot in the sky and recorded it with crude telescopes. Today, we can observe the inner workings of the explosion, measure its neutrino output, study its electromagnetic spectrum in detail, and detect its gravitational echo. The next supernova, if close enough, could answer fundamental questions about matter, energy, time, and the evolution of the universe. Brian Cox highlights the role of collective attention. When something like this happens, the world doesn't just watch, it wonders. And wondering leads to questions. And questions lead to discovery. The explosion of Betelgeuse could inspire a new generation of scientists, just as Apollo inspired a generation to look toward the moon. But in this case, we're not launching a mission outward. We're witnessing the cosmos sending a message inward. A brilliant, burning reminder that we are part of something vast, ancient, and still unfolding. If Betelgeuse goes supernova within our lifetimes, it will likely appear as the brightest object in the night sky besides the moon. It could cast shadows on the ground, change the way we see the stars, and even shift the cultural perception of space. Books will be written, documentaries will be filmed, and every schoolchild will learn the name Betelgeuse not as a myth, but as a real event witnessed by billions. Cox warns that we must be prepared, not in fear, but in readiness. Instruments must be tuned. Telescopes must be watching. Data pipelines must be clear. When Betelgeuse blows, it will give us only one chance to record the event in its full glory. The photons that leave that dying star will travel across space for hundreds of years before reaching us. When they arrive, they bring not just light, but information, clues about what happened in the final milliseconds of the collapse, and perhaps even hints about what lies beyond a supernova, such as the birth of a neutron star or even a black hole. Some theorists speculate that Betelgeuse might already be dead, that the explosion has already occurred, and the light is simply on its way to us right now. That possibility adds a layer of suspense to the entire narrative. We might wake up tomorrow and find a new star in the sky, bright, bold, and unmistakably not there the night before. If that happens, it will confirm the suspicions of many scientists and vindicate the concerns Brian Cox has voiced. Until then, the scientific community watches and waits. Satellites monitor its temperature. Ground-based observatories scan its surface. data from the James Webb Space Telescope continues to flow in. The eyes of Earth are fixed on Betelgeuse, waiting for the inevitable. We may not know the exact hour, or even the exact decade, but we know that its death is coming. And when it does, it will be one of the greatest cosmic events humanity has ever witnessed. Brian Cox's message is clear. This is not a moment for fear, but for wonder. A supernova doesn't threaten us, it enlightens us. It gives us a glimpse into the profound and powerful forces that shape the universe. It reminds us of how temporary everything is, and how magnificent the life cycle of a star can be. Betelgeuse's explosion will light up our skies, but more importantly, it will light up our understanding. It will mark a moment in history where the cosmos revealed itself not as a cold, distant void, but as a vibrant, ever-changing story, one in which we play a small but conscious role. So as Betelgeuse pulses, flickers, and sends out its final gasps of stellar breath, we remain here on Earth, watching, waiting, learning. One day, perhaps soon, we'll look up and see a light so bright it changes everything we thought we knew. And on that day, Brian Cox's warning will echo in our minds, not as a prophecy of doom, but as a celebration of science, discovery, and our deep connection to the stars.